In this module of Chapter 8 on Human Demography, Module 8.6, I cover the first of two life table models on health demography, this one on active life expectancy, including concepts, the basic model, and worked example. Health demography is the application of the content and methods of demography to the study of health status and health behavior. Thus, health demography concerns itself with the manner in which such factors as age, marital status, and income influence both the health status and health behaviors of populations, and in turn how health-related phenomena affect health attributes. However, mortality and cause of death statistics based on death certificates continue to be the mainstay of health assessment in demography and epidemiology. The study of health biodemography in general and the computation of health expectancies in particular were first developed to address whether or not longer life is being accompanied by an increase in the time lived in good health, i.e. the compression of morbidity, or in bad health, morbidity expansion. The basic concept of health expectancies is to divide life expectancy into life spent in different states of health. Disability is a general term for a health condition that limits functioning. More specific metrics for assessing functional limitation using multiple measures and are termed activities of daily living, that is ADLs, which are concerned with a personal care routine such as eating, dressing, toileting, grooming, transferring in and out of bed, and bathing. Disability measures that include more complex routines associated with independent living are instrumental activities of daily living, IADLs, which include using the telephone, shopping, and handling one's own money. Combining data on health or disability status of populations together with mortality data in a life table can be used to generate estimates of expected years of life in various health states. A general model of mortality, morbidity, and disability is presented in this figure. The area under curve A represents the healthy life expectancy. In other words, the number of person years lived both morbidity and disability free. The areas between curves A and B and curves B and C represent the number of person years lived with a chronic condition, that is morbidity, and the number of person years lived with a disability, respectively. And the combined area between curves A and C represent person years lived with a chronic condition, morbidity, and disability. These survival curves make it possible to more precisely distinguish changes in health and advanced ages, and such measures of population health are important for a number of reasons. First, they make it possible to compare the health of one population with the health of another population. These approaches make it possible to compare the health of the same population at different points in time and to identify and quantify health inequities within populations. At the policy level, they can thus be used to inform debates on priorities for health service delivery and planning, and to analyze the benefits of health interventions for use in cost-effectiveness analyses. Moreover, it should be noted that disability is not necessarily a permanent condition, or one that inevitably precedes death in the older population. It is also associated with both fatal and non-fatal chronic conditions, so it does not necessarily represent the final stage of poor health prior to death. The Sullivan model. Disability-free life expectancy is a summary measure of a population composed of two sets of partial measures: age-specific death rates and age-specific rates of population morbidity, disability, or health-related quality of life that accounts for the morbidity. This model, described below, is similar to a multi-state life table in which the individuals alive at age X of the life table are disaggregated into two or more states, healthy or unhealthy. The method to estimate healthy life expectancy, HLE, expected number of years in good health, is based on the Sullivan model, where DFLEX denotes disability-free life expectancy at age X, or the number of remaining years of healthy life for persons who have reached age X. LX is the number of survivors at age X, N pi x is the fraction of individuals age x to x plus n who are unhealthy. 1 minus n pi x is the age-specific rate of being healthy. NLX is the total number of years lived by a cohort in the age interval x to x plus n. Omega is the oldest age. Disabled life expectancy at age x, denoted DLEX, is given as this equation. Thus, total life expectancy at age x, EX, disaggregated into disabled and healthy components, is given as this equation. A worked example showing calculations for age-specific disability-free life expectancy is given in this table. We have column 1, which is age classes x to x plus 5. Column 2, the fraction of the original cohort surviving to age x, LX. This is the same as in the ordinary cohort life table. Column 3, NLX, gives the number of life years lived in the interval x to x plus 5. Column 4, 5 pi x, is the fraction of the population in the interval from x to x plus 5 who are disabled. This fraction is typically estimated from cross-sectional surveys. Column 5, 1 minus 5 pi x, is the fraction of the population in the interval from x to x plus 5 who are healthy, i.e. not disabled. Column 6 contains the number of healthy life years lived in the interval x to x plus 5. Column 7 is the time spent free of disability after age x, which is the sum of values in column 6 from x to the end of the column. Column 8, expectation of time to be spent free of disability, which is computed by dividing column 7 by column 2. The expected years of life, E naught, end of healthy life at birth age, that is age 0, were computed as 79.5 and 69.8 years respectively. The expectation of unhealthy life or of disability life expectancy at age 0 is then the difference between these two values, or 9.7 years. This means that a newborn woman, subject to the 1995 U.S. mortality and morbidity rates, would expect to live 79.5 years, of which 9.7, or around 12%, of these years would be unhealthy. Similarly, at age 65, the average newborn woman, subject to these rates, would be expected to live an additional 18.9 years, of which 5.1 years, or around 27%, or more than a quarter of these years, would be unhealthy. This ends Module 8.6 on health demography, concerned with concepts in a model of health expectancy.